Okay, so that last one might have been kind of scary for you, but it's really. Let's just try one more. Let's just try one more. Let's say we threw something real high, and it was and we threw it at it had an initial velocity in the y direction of 15 meters per second, and we want to know the time it was in the air. Okay, from going straight up to straight back down, so that we use this crazy formula, y equals v naught t minus, we know the acceleration because as soon as it left whatever shot it in the air, 15 meters per second, the acceleration on it is good old gravity, t squared. So it's going straight back. So it's zero in both cases. So the first zero is when time is equal to zero. So we don't even worry about that one, but we do have to factor. So we got zero is equal to, we'll take the t out of here. Now it'll be 15 minus 4.9 t. Okay, so you just see the pattern. You see the pattern. You just take this number minus this number times t, and then solve that equation because this t is equal to 0 is where it's here. This t is where it's gone up and come back down. All right, so we'll take 15 minus 4.9 t is equal to 0. 15 is equal to 4.9 t. Divide both sides by 4.9. And that's probably real close to 3.05 or something like that seconds. So that's a long time in the air, 3 seconds. So when people think, oh, Dr. J or LeBron, his hang time is 3 seconds. No, because he is not however high that would be. The height for that thing would be, so if we cut this height in half, if we cut this time in half and plugged it into this formula, we'd find the height that it went. So it'd go pretty high. Because what goes up, this is t over 2, and this is t over 2. So you can cut this in half, plug it into here, and you can figure out how high it was, what its maximum height was. Okay, so I didn't mean to scare you on that. But let's go ahead and go to the exercise. So the first 4 questions are pretty easy. 4, 5, 6. Now we get down here. Okay, what's his potential energy? What is his final energy when he's all potential energy? It's the mass times g, which is 9.8, times the height. So we've got that. Now, use the work energy theorem. With what velocity did he take off? All right, so we've done that. So let's take a look, so you can do that. So let's take a look real quick. Problem number 6. Problem number 6, what you're doing is 1/2 mv naught squared is equal to mgh. And so you're going to find that his initial, we've done that. You can go back and look at that and get the formula that you need for that, all right? So I'm going to stop here and we'll look at problem 7, 8, and 9.